When scientists set up an experiment, the way that they test their hypothesis is by having a variable. And so let's just start off with an example hypothesis. Let's say that I think that my houseplant will grow more if I give it a half cup of energy drink every day. In my experiment, I'll have one houseplant where nothing changes. So both of these houseplants will be exactly the same temperature, and they'll get the same amount of sunlight, but there'll be one difference, and that is called a variable. And so this plant over here would be the variable group, and this plant over here will be the control group. And the one thing that we're going to change in this experiment is I'm going to see if giving my plant a half a cup of energy drink every day will make it grow more. So here's my energy drink can, and there's some energy drink. The energy drink that we are giving to this plant, we would call the independent variable, because that's the variable that we're controlling. Independent. The independent variable. And the dependent variable in this case is the plant's growth. So let's just say growth. I'll switch colors here. All right, so the dependent variable is how much the plant is growing. Growth. All right, so there you have it. We have a control group where nothing has changed, a variable group where we're only changing one thing, the energy drink. The energy drink itself is called the independent variable because the independent variable is something that the scientist is controlling. And the dependent variable, how much the plant grows, is called the dependent variable because it depends on the independent variable or the energy drink.
Over the past decade, NASA's National Space Technology Laboratories, NSTL, in Bay St. Louis, Mississippi, has been doing plant-related research in purification of air and water for when people begin living in space. Many communities, including the city of San Diego and Disney's Epcot Center in Florida, have adopted research done at NSTL by using a plant called the water hyacinth in their treatment of raw sewage. This common weed, the water hyacinth, literally thrives on sewage. The plant has a complex root mass which acts like a filter, Bacteria and microorganisms that grow on the root system break down and digest the sewage, allowing the hyacinth to absorb nutrients, toxic chemicals, and even radioactive waste. The effluent that comes out of this system, which has treated sewage for a couple of days, is of such high quality that it needs only to go through a few final steps before it is drinkable. The hyacinth dislikes cold weather, but when in a warm climate, it grows at such a furious rate that it needs to be harvested on a regular basis. Once harvested, the plant matter can be dried for animal feed or shredded and loaded into a digester for further processing into biogas, which can be used as a fuel. The City of San Diego's Water Utilities Department has adopted the use of water hyacinths in a large-scale project to reclaim raw sewage and process it into drinking water. Another plant-related water filtration system recently developed through research at NSTL is called a rock reed filter. In this case, polluted Mississippi River water passes through granular rock containing reed plants. The roots from the reeds and the high surface area of the rocks support bacteria that break down pollutants and purify water. Since reeds can tolerate cold weather, this system works very well in regions where water hyacinths can't grow. The latest research at NSTL has been with a spider plant system that purifies air along the same lines as the rock reed filter does for water. Air is purified as it's drawn through the spider plant, interacting with activated carbon and the plant's root system. Dr. Bill Wolverton of NSTL.
Now, this is an exciting new technology that's emerging that we're looking at now. It not only allows fewer plants inside a home to purify that air, but it has tremendous applications for our future space station as we look towards developing a space station or a moon base or others. So these technologies evolving from aquatic plants to common house plants, we're beginning to put this technology together for practical, simplified, everyday use with the ultimate long-range goal of perfecting a closed ecological life support system for space application, be it a moon base or a space station.
Hello MTV, welcome to our crib. Ah! Why'd you say it like that? Okay, that's all.
Can you show us some of the plants?
Yes, we
I know
can.
them. Wait.
Okay,
I learned them today.
over here we have a pumpkin, and then we have some cucumbers. You
Wait.
can count them. Count them, Katie.
I got it. 1, 2, 3, 4, 5, 6, 7, 8 cucumbers.
And then we have some delicious kale.
Don't eat it.
No, I'm gonna do it. Oh, yeah.
What else?
And then keep going.
Shoot. Lettuce. Yes. Tomatoes.
Brussels sprouts.
Brussels. Dang it.
Brussels sprouts,
Tomatoes.
This is
Chilies.
jalapeno, chili, or conega.
We're not sure yet. It's
We're
a
not sure which is
surprise.
which. Then over here, we have another pumpkin. We have some more cucumbers. Kimmy, count them.
1, 2, 3, 4, 5, 6, 7, 8.
We have a real life shell.
It's real.
It's real and it's live. We have some lettuce that is delicious. I would eat some, but I'm
Romaine.
still chewing my
Romaine
kale.
lettuce. 2 romaine lettuces.
Broccoli,
More tomatoes.
more tomatoes,
Kale.
kale, and then exciting stuff over here.
Watch out.
Sorry,
Stepping
sorry,
on
sorry. With these pipes that we are freshly cut, we are gonna make some strawberries.
So, population growth means more mouths to feed. We eat a lot of fish, but the oceans aren't getting any bigger, and most of the fish we consume is now farmed. That includes salmon, an important source of long-chain omega-3 fatty acids that keep us healthy. But, in order to maintain high levels of omega-3s, salmon and other fish are raised on a diet of fish food that is sourced from the ocean, which could damage the ocean in the future. Get it? But what if we could get the long-chain omega-3s we need into fish food using, you guessed it, plants? If researchers take the right genes out of omega-3 producing algae in the sea, and put them into an oil-producing land plant called camelina. Then we could grow the food that farmed fish need to be rich in omega-3s. Scientists in the UK are working on this, and the impact could be massive. We could get omega-3 from a more sustainable source without depleting the oceans. That is one way scientists are making plants do amazing things.